Hi, my name is Alex Fleischman, and welcome to the video overview for the Van de Graaff generator demonstration. Alright, so the focus of this demonstration is the Van de Graaff generator, which will build up and distribute charge amongst its conducting metallic sphere. Let's go through the procedure. First, set up the Van de Graaff and allow the system to run as it acquires charge. Next, ask a willing student to place his or her hand on the metallic surface of the generator and observe the resulting effects. The student must stand on an insulating surface. Alright, let's go through some questions. What charge does the Van de Graaff acquire as it runs? Well, to answer this question, we first must take the sphere off the generator and observe the internal belt mechanism. Alright, the Van de Graaff's internal mechanism has two rollers, one plastic and one metal. Due to the nature of the materials, the plastic rollers acquire a negative charge, and the metal roller therefore acquires a positive charge. Since the metal roller is at the top of the generator and in contact with the sphere, it will result in a positive charge distributed across the surface of the sphere. So how does the charge behave when the student comes in contact with the sphere? When the student touches the generator, the positive charge is then distributed throughout his or her body, since the charge will always attempt to evenly distribute and acquire a net neutral charge. Why does the student's hair stick up when coming in contact with the generator? Since the charges repel from each other, they want to get as far away from each other as possible. Charge can distribute easily on your hair, since charge can spread out on each individual hair. Since each strand of hair acquires a positive charge, the strands repel each other, and therefore stand up. Before anyone was allowed to touch the generator, they had to place themselves on an insulating surface. Why was this necessary? Alright, let's begin by stating that the Earth is the world's greatest conductor. Therefore, if a student did not stand on the insulating surface, charge will flow directly through the student and into the ground. Once the student stands on the insulating surface, charge cannot travel to the ground. Therefore, charge evenly distributes throughout the student.